Hi everyone, in this tutorial we will build a payment contract, a secure and gas optimized smart contract for handling ERC20 and native token payments with whitelisting capabilities. We will use Foundry for smart contract development. Foundry is blazing fast smart contract development tool. We will build it from scratch, we will test it and we will deploy it. This video will be so long, so I decided to divide it into two parts. So make sure you have installed Foundry in your system. To install Foundry, you can go to book.getfoundry.sh and in the sidebar you will see in getting started installation. Follow the installation process and install the Foundry according to your system. So without further ado, let's get started. Right, jump into uh, smart contract development and start building our smart contract. For that, we are creating a new folder and let's name it freshly new folder and let's name it payment and open it in our VS Code. Before go and let's initialize our project by running this command forge init. I'm in debug console and our project is initialized. Yeah, it's taking time. Maybe my internet is slow, but yeah, let's go. Here we go. Our project is initialized. We are going to use OpenZeppelin libraries to create and build a smart contract. So let's install OpenZeppelin by running this command forge install. I guess forge install OpenZeppelin dash contracts and hit the enter or the return in Mac. So while it is installing, let's delete these three files because we are going to start from scratch. We will build our own folder structure, all our own files and script counter.s.sol. While it is installing, let me tell you some cool features of our smart contract we are going to make and we are going to build, and we will accordingly design our smart contract. So the first feature support, we will add support for both ERC and native token payments, and the second, another token whitelisting with enable and disable functionalities we are going to add. Also batch token registration also we are going to add, and secure payment claiming by the contract owner. And the most important, we will add the reentrancy protection of our for our smart contract, and I will show you some gas optimize error handling, and at the end we will after that we will test it rigorously. We will write some of the beta test and we will write deploy script, and after that we are going to deploy it on Rootstock network. So let's start writing our smart contract. For that, let's create a file name inside the src directory. Let's name it payment.sol and let's start writing our smart contract. For that, let's pragma solidity, and I have added some auto completion here. So license identifier MIT pragma solidity 0.8.20. You can use 90 or make sure you are using stable version. So let's name our contract payment thanks to Copilot. So our payment contract should be ownable and reentrancy card. So let's name it ownable, and so as we installed OpenZeppelin libraries, we have to set remappings, and we have to import this ERC20. We have to import ownable and reentrancy card from the OpenZeppelin. So let's import. Make sure you are importing just as me. Thanks to Copilot. This is the best practice. We should always, when working with Foundry, you should always named import when you are importing external libraries from lib. Import re-entrancy card from entrancy.sol, and we also need IERC20. Let's import fast one by one. IERC20 from token IERC.sol. We also need to import safe ERC thanks to Copilot, and make sure you are setting your remappings, because if you do not set your remappings, you will struggle with compiling, and it will give you an errors and also some red ugly lines. So to set remappings, run this command forge remappings.txt and hit the return. You can see Foundry will automatically generate this remapping.txt file, and it will set the remappings. So let's go ahead and continue with our smart contract. It should be ownable and reentrancy. You can see source flash file not found because we forgot to not this. It should be at open Chaplin contracts access ownable.sol. It's where this coming from. It is also open Chaplin contracts utils reentrancy card. When working with AI, this happens. Open Chaplin contracts token ERC20. I'm just fixing this at open, just hitting tab. ERC20. This is coming from lib open Chaplin library just we installed. You can go here and check out the path ERC20. You can go here inside the contracts. Where are the contracts? And inside the contracts you can find the token. Inside the token you can find ERC20, and you will see ERC20.sol. IERC20. This is just we imported, and ERC20 inside the utils you can see SAP ERC20. This is the contract we are importing, and we are going to use the functionality of this libraries we are importing. So let's go ahead and let's continue with our smart contract. Let's first declare using safe ERC for IERC20, and that's correct. Why do we use this safe ERC? This is the important you must know as a smart contract developer. We use safe ERC to safety and interact with ERC token because not all ERC tokens follow the ERC20 standard in this blockchain world, and some can behave in unexpected ways. So we should it's always a good practice to use as a professional smart contract developer CPRC for IRC20. Let's go ahead and initialize our state variable. So we are going to use only one state variable, that is mapping, to track whitelisted tokens. Let's mapping, it should be address to bool. I hope you know how mapping works in Solidity, and you have basic understanding of Solidity. Public, let's name it whitelisted tokens. Whitelisted tokens. And why these curly lines? Let's wait. I will cover this because we are not using constructor yet. So let's declare our constructor, and constructor should be ownable, and inside that ownable constructor should be ownable. Inside that ownable we should pass the message.sender to set the message set the contract owner, right? We are still getting the error. I don't know. Let's fix this. Maybe this is just because of my VS Code configuration. No argument past the best construct specified argument payments are solved. So it's okay. We will. Yeah, this is my VS Code problem. It is not actually the problem. So let's go ahead and write our first function. Our first function should be first function is register token. We are going to register token for payments, and for that let's start writing function register token which will take address and the boolean as whether it's enabled or not. So let's let's take a parameter address of token and a boolean value of whether it's enabled or not enabled. Let's make it public. No, not a public, actually it should be external. That my bad. And the only owner. So actually where this we didn't declare. Most of you are the advanced or someone who has little more experience. They should have question where this only owner is coming from. So only owner is coming from the inheritance that we set here in ownable, right? So let's here initialize our mappings. Whitelist token, and inside that we should pass this token, right? And it should be, let's say, enabled, and we have to emit an event. So let's declare an event on the top of yeah, there we go. Here we should add events, and what events we have to token registered and token and enabled. Let's here we go. Here we have to declare token registered address token boolean enabled. So address should be indexed because when you are working when you are trying to connect this contract to front end, it will be very beneficial for you. So let's format document again once and start writing our second function. So second function, let's pair. Let's declare second function such that PERC20, and inside that we have to take 4 parameters. The first is address token, and the second is event amount, and again we have to pass the string call data, and let's name it user ID, for example, user ID, also the product ID, right? String call data product ID. Let's make it external, and for the security we are going to use non-reentrant here. Let's external non-reentrant what happened, non-reentrant. And now inside that we have to write logic. If not whitelisted and token thanks to Copilot, it should revert, because we are not going to use it, should revert token not whitelisted, and we have to declare this custom error. We are using this custom error just to save gas fees, right? Because as I promised, I will show you some of the best practices of smart contract development. This error and token not whitelisted, right? This is the error we declared here, and we are using this here. And now we have to again use if amount. This is the amount as a parameter. If amount is directly is equal to 0, we should revert it as a zero amount. Inside that as nothing, let's declare this in our error, and that is the custom error, zero amount. Thanks to Copilot again. And let's go ahead and write IERC20 that we are importing. Just copy it from here. I love copy pasting. And inside that we have to pass the token, and we are going to call here the shape transfer function dot shape transfer, and inside that shape transfer we are going to pass message dot sender as well. Let's say address this and the amount, and let's emit the event here. What is this curly line? Wrong argument, 3 arguments given but expected to. Something is wrong here. IERC20 inside that token shape transfer. Yeah, we are going to, we forgot to add from here, shape transfer from, and let's emit the event here, and let's name it payment event. Inside that payment event we have to pass token, amount, user ID and the product ID, thanks to Pilot. And we didn't declare the event yet, so let's go here in our event. Let's event and the payment event, and in the payment event we have to pass bunch of things. First the address, it should be index, and the token, second address index from, and again 7256, the amount, user ID and the product ID, thanks to Copilot. It's almost done. Yeah. Why this line? Because my VS Code is slow. It will go away soon. And now the third function we have to write is to pay native, because it is important. As I said, we have to add pay native here. So let's write the logic of pay native here. Pay native function here, pay native, because, and inside that pay native we have to take parameter as a call data as a user ID and the product ID. So let's write first is a string call data user ID and string call data product ID, and it should also be external, but this time you have to make it payable. So external payable, and it also we have to make it non-reentrant for the security. Expected 5. I think we forgot to add one more here. What we forgot in event, we index token from, here we forgot to add message dot sender. It happens sometimes. As a developer you have to identify error, and let's fix. We have to fix it right there. So let's inside the function let's format again one more time. Or by the way, I will show you the one Foundry's command that will format your document. You can do forge fmt, and it will format your entire code base. You can see here, right? This is another tip I would like to share with you. So let's start writing our pay native function logic. So if not whitelisted tokens, and inside that address 0, it should revert, not here, it should revert token not whitelisted, token not whitelisted. So I think yeah, we already declared error here, and now we also check if message dot value. So let's write if let's say message dot value is equal to direct 0, it should revert 0 amount. That's it. Let's format it again. Why do I format again and again? It helps me to check I'm on the right path, and it also beautify my code, well documented code. So now it should emit an event, the payment event, address 0, message dot sender, message dot value, user ID, production ID, thanks to Copilot. Yeah, and now we have to write the functionality for the claim payments, and also get contract balance, batch register tokens. These are the 3 functions more we have to write. Let's start writing first function for claim payments. Function claim payments. You might have guessed only an owner can claim the payments. So let's take a parameter as address of the token and the amount. Let's make it external. It should also be only owner and non-entrant, as I said, for the security. Let's start writing the logic. Let's check if token is equal to address 0, and inside that if condition we need to add one more if condition, amount. If amount is less than address, this dot address, inside that we have to pass this and dot balance. This dot balance, it should revert insufficient balance. Right, and we need to declare this error on top of our errors. Let's declare here insufficient balance. Now let's go outside our if. Not actually, we have to declare here a variable. Let's a boolean variable. Success should be equal to owner. Let's call here the dot call. Inside that call we should pass value as an amount. Let's copy it from here and close this. That's it. It's I think we forgot to add here address owner. I think owner undeclared. Did you mean owner? Yeah. Did you mean owner? I think yeah. It gone away. Right. Now let's add if here, and if not success, copy it from here because undeclared, it is showing undeclared, and not if not declared. Sorry, if not success, it should revert transfer failed. Yes, transfer failed, and we need to, oh my bad, we need to declare this transfer failed on in our errors. Error transfer failed, and here we go. Transfer failed. Now else, inside the else, let's take a local variable uint 256. Let's name it contract balance, or even contract BA track balance is equal to IERC20. That we have to pass token is to copilot and dot balance of, this is the function, and address this thanks to copilot. Now if amount is less than contract balance, that is the variable we declared here, it should revert insufficient balance thanks to copilot. And now let's IERC20. Inside that we have to pass token, and we are going to use here the safe transfer, and inside the safe transfer we have to pass owner and amount, the safe transfer function. Let's format document and go outside this if and else condition and emit an event name payment claimed, PAMENT claimed, and in this we have to pass token and amount thanks copilot. Let's declare this event in events. There we go, our third event, payment claimed, address index, and address index token and the amount that we declared the emitted the event here. Now let's to enable the contract to receive some tokens, we need to pass the receive function. We need to create receive function here that we forgot previously. Receive, and inside it should you must know this should always be external and payable, and we are not going to pass anything here because this is the standard, right? What is this error? What is expected identifier? This is my VS Code error, and if there is still error we will see it later. Let's start writing our next function, get contract balance. It's a very simple function, so let's start writing this function, get contract balance, and take a parameter of address token. It should be external view, external view returns entity 56 file, and it should this is not a good suggestion copilot, I'm sorry. So here we have to write some logic. If token is equal to address this address 0, it should not revert actually right now. It should return address this dot balance thanks to copilot. Else it should return what it should return? It should return IERC 20, and inside that we are to pass token IERC 20. Inside that we have to pass token dot balance of and address this. That's it. This is our function ready. Now we have to write our last function, that is batch register tokens. This is one of the important function we are adding in our contract. Let's start writing function batch register token, batch tokens, and we have to take some parameters, the array of address, it should be call data, and tokens, the array of bool call data, the values. Let's make it external, and only owner and start. Let's open our function body. Before moving, let's format our document, and inside that we have to take, let's take it a local variable into 256 length h length is equal to tokens.length. Thanks to Copilot again, and now it should require, and inside that we have to pass this length, the length required to be equal to values.length thanks to Copilot. Otherwise we have to revert, or let's not revert, let's take a string length mismatch, mismatch, and we will run a for loop here. As a solid developer working with loops, it's very important, and we have to, when you are using loops, be very careful, because you can run out of the gas, and blockchains are very costly. Not Rootstock. For let's write our loop. This is joke aside. Rootstock is for, let's say, uint 256 I is equal to 0, I is less than length. Oh shit, I is less than, I just want to copy this only, I is less than and plus I. We have to, and I think, yeah, here I made the mistake. Whitelisted, let's use our mappings here. Whitelisted tokens, where is our mapping? Let's copy it from here and declare here whitelisted tokens, tokens I, and value should be I, and here we have to emit an event token registered, and the token and the value of array, and we forgot to we have to declare the event here. Here we go, address index token, and will not enabled, I think. Oh shit, we forgot event here, and let's format where we are getting error, we are doing something wrong. Receive expected identifier, I forgot my spelling mistake here, RECEICE, and so let's format again. Now it should go away, and here is another error, 83, address this, what's wrong, if token is equal to address is equal to 0. Yeah, I think I made, yeah, I added, it's very simple, I forgot to, and here I forgot to add the return correctly. This happens. Let's format it, forge fmt, and pass something I did again here, else IERC20 token. Let's try to format again, I did something wrong here. Let's 94, yeah, for int, yeah, I have comma here, and again here. Let's try to format now. Now it's formatted. So this is my VS Code. Sometimes you don't token registered. Yeah, we token registered. We already let's remove this. We already declared this event. I forgot it, and format again. Now it should. Let's clear our terminal, and let's format again, forge build, not build before building, or format, and let's see our contract is building correctly, filing correctly. by running this command forge build, and it is giving us some warning. Named returns variables and on event 256. What we are returning inside this 67 file, 67 yeah, event 66. This is just minor warning. You can think it as a balance. Let's build, and you can see here our compiler runs successful, and we successfully implemented the functionalities of our payment contract. So this is part 1. In the next part we will test entire smart contract rigorously. We'll write some of the BADAS test, and we will deploy it on Rootstock network. So you can see here, so far we initialize our smart contract Foundry project, and we created a new file inside the source directly, that the payment soul, and we declared a state variable, some events, errors. The constructor is ownable, the first function register token, the pay ERC20 token, and pay native token, pay native function, also claim function, the claim payments for the owner of the contract, for the get contract balance, and batch register tokens. And I will see you in next part 2. Thanks for watching. Bye bye.